reiterate them in your mind. Somehow or other it happens. All right, here's what I wanted to do tonight. I've been getting an awful lot of questions about what's happening at the Fukushima reactor, what's happening with pollution, what's happening with the contaminants, what's happening with the radioactive elements and the radioactive species that appear to be belching into the air and into the water. And so I thought I would go through filtration technology a little bit because, A, it's good to review, but also because it's relevant to questions that I'm being asked every day from the distributors wanting to know what it is they can do or what can be done for the people in Japan in order to ameliorate the problems that are coming out of the Daiichi reactor. So let's start with the water technology. Nikon has several different formats for the technology, several different configurations, except for the shower head. All of them are based, at least in part, on activated charcoal as their ability to provide their ability to filter the contaminants out of the water. The shower head itself is actually more like a catalytic converter, but I'll get to that in a little bit. Let's talk a little bit about water facts. For those of you who are not looking at the PowerPoints, I will reiterate that water is absolutely fundamental to our life. It's vital to almost every bodily function. The best source of water is pure water, water itself, and of course PyMag water would be the ultimate source of drinking water. Soft drinks and alcohol tend to steal water from us because coffee, milk, even juice, they require more water from our body in order to be diluted, in order to be properly digested. Water is essential for proper digestion, for nutrient absorption, for proper circulation, helps to flush toxins from our systems, and helps the body thermoregulate. There's a picture of the water molecule. It's H2O. They're the two hydrogens, or the little green guys that look like Mickey Mouse's ears, and then the oxygen is the large yellow body, which is the most of the face. What's interesting about this slide is it's showing that there's a net dipole moment. There's a net charge on the water molecule. It's slightly positive up between the two hydrogens and slightly negative at the opposite end of the molecule, which means it has a charge, which means every water molecule is like a tiny magnet. So that when you put them together, they will structure themselves, they will order themselves, they will clump, they will aggregate in accordance with the electrostatic charges. Here's one that I get asked all the time. This is pH. pH actually stands for potential for hydrogen. When the water molecule ionizes, when one of those H plus hydrogen ions leaves its family, leaves the molecule, leaving behind an OH minus and an H plus, that's called ionization. Charged species are called ions. The balance between H plus and OH minus determines the acidity or the alkalinity of the solution. When the concentration of hydrogen ions, or the H pluses, exactly equals the concentration of the OH ions, or the alkaline ions, then the pH is said to be neutral, or 7. And you can see from the scale here that as you go up in value, you actually increase the alkalinity, and as you go down in value, you increase the acidity. So a battery acid, which is hydrochloric acid or sulfuric acid or a mix, would be at a pH of 0. Milk is about 6, and water is exactly 7, and then you start getting into the alkaline where you have baking soda, seawater, ammonia, and lye, all the way up to a maximum pH of 14. So the question is, what about the contaminants in our tap water? And of course, the number one major contaminant that everybody's worried about is chlorine. Why do we put chlorine in the water? Well, we have two major health hazards or health concerns with water. One is short-term and one is long-term. The short-term would be if you have pathogens or bugs, bacteria, viruses, whatever the pathogen may be in the water, and you drink it, you have a short-term health challenge. You're going to get sick. So what we do is we take a poison, we take a pesticide, in this case it's chlorine, and we dump it in and mix it with our tap waters. Our municipalities do this, and we want to kill the pathogens that are in there, the bacteria that's in there. And it does a great job, and it's cheap and it's inexpensive. The problem is that in combating the short-term potential health risk, we invite ourselves for a longer term where we have chlorine, chlorinated compounds, chlorinated organics that give us a problem downstream, no pun intended. PyMag water was first identified in Japan over 30 years ago. Scientists found a remote area where a combination of geographical features produced water that had unusual properties. In this region, a narrow stream which passes between two hills containing magnetite as well as other compounds including calcium derivatives, was found. And they discovered that the water from this stream had amazing results on the surrounding plants. They named Pi water the water of life, and they set out to duplicate it in the lab and to duplicate it in our water technology and create what we now know as PiMag water. Let's take a look at the AquaPur gravity water system first. This is a portable unit that you can use just about anywhere in the RV, at your home, on the countertop. Take it with you, the classrooms, in the office, wherever it may be. It features a natural filtration process using gravity as the power source instead of plumbing it in, instead of needing water pressure in order to do it. It is portable, economical, multi-stage. Water passes through 5 stages of filtration, and that's going to be the focus for tonight. And then, of course, it has the magnetic technology, which is the filtering of the water as it passes through the magnetic field. The AquaPur features, this is the deluxe, this is for the top of a dispenser, which I think many of you may know, but what I want to do is talk about the filtration itself. We have 2 pre-filters. One is a microsponge, the other is the ceramic pre-filter. One is used to reduce particulates that are in the water when it's not too onerous, when it's not too difficult. The other is a slower filtration, but it's a higher intense filtration when you have high levels of heavy metals like iron and copper present. This is the meat of it, and this is what I want to talk about more or less tonight, what I want to focus on with the water. The filter cartridge shows the activated carbon, which is a simple natural form of absorption, of filtering, reducing chlorine, unpleasant odors, and colors. There's the Pi ceramics, which helps condition the water. There's ion exchange resin, which acts to help soften the water. And there's zeolite in here, which is important for tonight because it has a granular material that is, again, mined from the earth, which is tremendously valuable in filtering and also helping to do ion exchange and reduce the hardness. So let me talk a little bit about an email that I got a little while back from Grant McNabb. And what he asked about the ability of the PiMag systems, of the activated charcoal systems, to filter drugs. And what I pointed out to Grant was that the NSF standards, NSF 42 and in particular NSF 53, for which the under-the-counter, the countertop comply, and for which we also have some very impressive data on the AquaPur, do an excellent job of taking out organic compounds. And I have to differentiate here because there's organic in the sense of growing things and planting things and harvesting things. And then there's the chemical organic, which has to do with compounds that are made of carbon, hydrogen, oxygen. And it's that organic, it's the chemistry organic that I'm talking about here. And it's those kinds of organic compounds that we test for using chloroform as a surrogate. And based on the performance of chloroform, we can then extrapolate, or we can then divine that we will be effective as well on other types of organics, including most pharmaceuticals. I guess I can't think of too many pharmaceuticals that are non-organic from a chemistry sense. And one of the ones that's key that we're seeing everywhere is synthetic estrogen, which comes, of course, from the pill, which comes from the contraceptive pills. It's made by man. It's made to mimic estrogen, and it is very robust in that it doesn't break down very quickly, so that when people who are on the pill go to the bathroom and flush it away, it gets into our water systems, it gets into the aquifer, and it's in our tap water. And so the question is, does the PiMag, do the cartridges, do the activated charcoal, do our systems actually take out these kinds of drugs, these kinds of pseudoestrogens? And the answer is we believe it is. We have not tested directly for it, but using chloroform again as the surrogate, we can extrapolate that it will do a very good job. Okay, so Grant went on to ask me about a friend of his who has had perhaps 50 or so Japanese exchange students staying with them, and wanted to know when they go back home and have their environments challenged by these isotopes, by these radioactive isotopes from the Fukushima plant, what can they do? How can they protect themselves a little bit at least from what's going on? And one of the things that I said was, first you have to look at what's actually coming out of the failed reactor itself. It's not unlimited numbers of isotopes, radioactive isotopes. It's actually, the last I saw, and I looked at it again today online to make sure that I was accurate in my information. So far, what they've identified coming out of Fukushima is two types of iodine isotopes, I-131 and iodine-132, as well as tellurium and cesium. And what I wanted to do, let's talk about iodine first. All these isotopes, all these radioactive compounds, what you don't want to do is get them inside of your body. You don't want to get them in your body because they tend to stick and stay. They'll find a home, particularly iodine. As we know, iodine is absolutely necessary for us. It's part of our metabolism. It's part of who we are. It's part of what we need. That's why we need to have our salt iodized. And for those of us who don't eat a lot of shellfish, it's extremely important that we have the little bit of iodine that's included in our table salt, being included in our table salt so that we're healthy. So when you have radioactive isotopes of iodine, they can be problematic if they get inside your system. So what you want to do is make sure that you don't take them in. You don't drink them in your water. And of course, one of the things that's great for filtering these isotopes out of the tap water, should they get in there, is activated charcoal. So whether you're using the Niken PIMAG systems or some other system of activated charcoal, it's ironic that the ratings on activated charcoal are actually done in what's known as a iodine index, and they look at the ability of a gram of the activated charcoal to filter out a certain particular weight of iodine. It's called the iodine index. So iodine, just like chlorine, is very nicely and very effectively taken out of the water by using activated charcoal. The other interesting thing is that once they're retained by the filter, they're not much of a problem because the half-lives of I-131 and I-132 are 8 days and 2.3 hours respectively. So what that means is that the ability for these isotopes to remain stable is on the order of 8 days or 2.3 hours respectively, which means if you start off with a gram of radioactive I-131 on day 1, by the time day 9 rolls around, it'll be half a gram of radioactive and half a gram of non-radioactive. Wait another week, and it'll be half that again, and half that again, and half that again. So even if it's trapped in the column, if you wait a month or so, it's not going to be much of a hazard because there's not going to be a lot of radioactivity left. It will have been discharged. It will have been emitted by then. And the I-132 is even less of a problem once it's trapped in the filter because the half-life there is 2.3 hours. So let me just say that as far as the two isotopes of iodine are concerned, getting them out of the tap water is not a big challenge if you have a decent activated charcoal system. Cesium is a little bit different. The cesium isotope, and again, let me go back to iodine. I don't mean to be scattered here, but I wanted to point out that if you were to drink water contaminated with radioactive iodine, the chances of it integrating, being held in your thyroid, being held in your system is very, very large because we need iodine. We tend to concentrate it, and we tend to have it locate in our thyroid. And the problem there is if it's radioactive, it's all going to be concentrated in one spot so that the radioactive emissions are also going to be concentrated in one area, and the chances of you doing damage are going to be much greater. The cesium isotopes are a little bit different because although our body needs a small amount of cesium, the cesium itself isn't localized in one organ or isn't localized in one place. So even if you were to take it into your body, it would tend to be dispersed. And the half-life of cesium is from 2 to 30 years, depending upon the isotope. So even if you had a small amount of cesium in your body, it would tend to be dilute. It would tend to be not concentrated in one place. And it would also be many, many years before it would actually discharge its energy, its ionizing energy. So it tends not to be as much of a problem. At the same time, the zeolite that's in the column here that you can see on the filter cartridge will also act to gobble up or to grab up the cesium so that the chances of it making it through the zeolite bed is very, very low. Now, I also have to point out that we haven't specifically tested our columns for their ability to absorb and retain radioactive iodine isotopes, nor zeolite, but I'm telling you that based upon what we know about how these compounds act, how these absorbents act, how these ion exchange, or in this case the zeolite acts, the chances are very, very good that they'll be quite effective. The wild card here is tellurium. Tellurium isn't a compound that we need, so it isn't something that you probably will retain in your body. The half-life of tellurium is about 80 hours, so the chances of it being a real risk to your health, even if it's in the water, isn't that great. Okay, I'm not going to burden that anymore. I'm going to move on. The other parts of the PIMAG Aquapure are the mineral stones, which help to add some natural alkalinity as well as to soften the water. And then we have the 1800 Gauss toroidal magnet. That is the last stage that the water passes through. All right, here are some of the specifications. I'm not going to go over them because I just simply don't have time. But you can get them online. You can read them online. They're all there. And the countertop is next with stainless steel design, LED features that tell you when to replace the filter, requires no electrical plug-in, easy to set up, compact, space-saving design. Under counter features, same filter. The filters are interchangeable. It gets it out of the way, gets it out of sight under the sink, includes a durable chrome faucet, and again has the indicator light telling you when to replace the filter. Relies on the pressure from your water in your house, but doesn't require any electrical plug-ins. It has a battery, a lithium battery that lasts for several years. That drives the LEDs for the indicator. Here's a multi-stage filter. This is a cross-section of it. You can see that the vast majority of it on the outside is activated charcoal, which again we talked about. It's got block and particulate activated charcoal. What's interesting about activated charcoal, besides the fact that it has this iodine index and that it's very good with chlorine, it's very good with other contaminants, is the fact that it has a surface area that is, kind of like the Thomas's English muffins, the nooks and crannies. The nooks and crannies that are in there are ready to absorb the contaminants from the water, pull them, bind them, and hold them. If you take a look at a gram of activated charcoal, and when I say a gram, this would be about a thimbleful of activated charcoal, has the surface area of a soccer field, which is mind-boggling if you think about it. This small amount of powder that would fill up a thimble actually has surface area collectively of a soccer field, a football field. Quite amazing. And, of course, that tells you why it's so good at being able to reduce contaminants at greater than 90% for the life of the filter. It is NSF, both the countertop and the under-the-counter are NSF certified. NSF certified for 42, which is taste, odor, aesthetics, and chlorine, as well as being certified for 53, which is heavy metals, which are inorganics as well as organics, like the chloroform and also chloramine. A short segue on the PIMAG Ultra Shower System. It does have advanced redox, which is reduction, oxidation, filtration. It acts essentially as a catalytic converter rather than a filter. It has fine particles of zinc in there as well as a catalyst, which catalytically take the free chlorine, went ahead a little bit, catalytically take the free chlorine, convert it to zinc chloride, which is benign and inert and just bounces off your hair, bounces off your skin, goes down the drain, instead of interfering with your shampoos or your soaps or causing dry, patchy skin or causing your hair to get dried out and frizzy. All right. I'm going to move on to the Air Wellness now. Here's the Power 5 Pro. And I think this quote from the EPA is pretty well known, and that is that the air within our homes and other buildings can be more seriously polluted than the outdoor air, even in the largest and most industrialized cities. A danger to health is ozone as well. Our unit doesn't rely on ozone, but doesn't scrupulously avoids producing any ozone so that we can be healthy and happy. Air pollution is a major cause of lung disease, which kills 335,000 Americans each year and is the third leading cause of death in the United States. That's from the American Lung Association. Here's a quote from the California Air Resources Board that in one study, the U.S. EPA ranked indoor air pollution as the fourth in cancer risk among 13 top environmental problems analyzed. Inhaled lead particles are a serious health hazard, and an estimated 83% of privately owned housing and 86% of public units still contain some lead-based paint. That's the American Lung Association. Daily exposure to indoor contaminants is 2 to 5 times higher than exposure to what's outside, and 90% of our time is spent indoors. Everyone in the family is at risk. Children spend even more of their time at home playing video games or whatever, so do the elderly. So we move into the Air Wellness Power 5 Pro, clinically clean, naturally fresh. The only air system that combines all of these. A laboratory-grade multiple-stage air filtration system, negative ion generation, patented ozone-free operation, an air quality monitor and automatic mode, and green technology to protect the environment. These are some of the endorsements that we have, the British Allergy Foundation, as well as SCARF, which is the European Center for Allergy Research Foundation. The filtration stage unit neutralizes 99% of the test contaminants within a half an hour of use. These are organic contaminants that will pass through. Repeated testing after an hour shows up to 100% of inactivation. Energy Star efficient, which means we're environmentally responsible. We use minimum amount of electricity at maximum power, 46 watts at maximum setting. Lowest is 5 watts. Other units require twice as much power, so we have been awarded the Energy Star designation from the U.S. EPA. We are at least 35% more efficient than a standard room air cleaner, and costs you less to run and is better for the planet. It's very quiet when you have it on the max, which is the turbo setting, where it's the maximum turnover of air. You're only at 45.4 decibels. The sound level in a quiet library is 60 decibels. And I can tell you, I've had a Power 5 Pro next to me in the bedroom now for years, and it's on turbo all the time, and I sleep like a baby. It doesn't keep me awake at all. Silent mode, dust reduction mode operates the Power 5 at alternating speeds. It's optimized to clear the air quickly in exceptionally dusty conditions, and these are rather large particles that we're talking about here. Silent mode maintains automatic operation within the low range of fan speeds and is ideal for bedtime. Air quality indicator, this is a light which is kind of a light blue, as you can see here on the slide, when things are looking good, and then it turns gradually yellow and then red as there are more and more contaminants, more and more particulates in the air, and provides a continuous indication of room air status. This is what I really want to get into now, are the different stages of the Power 5 Pro, the different stages of the filtration. There's a pre-filter mesh combo, which is really going after the big stuff, pet hair, feathers, that kind of thing. Is made of long-lasting reusable material. You can vacuum it, you can take it off, you can dust it off, and clean it off. It prolongs the life of the filters that are inside and helps the entire system to deliver maximum performance. The second one is this neutralizing filter that I was talking about, particularly when you have organic contaminants. So this can be organics in the form of gases, or it can be organics in the form of other kinds of either living things or viruses, that sort of thing, where the extracts there's a plant extract material that's integrated into this fluted filter that you can see here that disrupts the irritant properties of these particles without using any synthetic chemicals. The next one is extremely important for what we were talking about before with the contaminants coming out of the Fukushima area, and that is both with the iodine as well as other gases. This activated charcoal carbon filter is simple yet highly effective means of reducing contaminants. It has great absorptive properties where matter will adhere to the surface, will get stuck, will get absorbed, and will stay there. Activated charcoal is naturally treated with oxygen to open up millions of tiny pores. I talked about the surface area. The surface area that's used in the activated charcoal found in water filtration systems is very much akin to what we have in the Power 5 Pro, which results in highly porous carbon, surface areas up to 2,000 square meters per gram. 2 grams less than a teaspoon equals almost a football field. I think I just about said that. And then the final stage is a high-quality fluted HEPA. HEPA is just a code for high-efficiency particulate air, and then the filter is the part you fill in, so I guess it should be HEPAF, and that way we would know it's a high-efficiency particle air filter. First developed for use with nuclear reactors, and one of the reasons that they wanted to use it with nuclear reactors is they have a lot of particles in the air that are dangerous, that are radioactive, that are hot. And what they want to try to do is to pull the air in that environment through the HEPA filters, trap the particulates, trap the cesium, trap whatever it may be in the HEPA filter itself, and either dispose of it properly or wait long enough for these half-lives to run through, like it would be with iodine. Wait a few weeks, and essentially you've got a filter that's no longer hot. These are used in surgical operating rooms to clear the air. Why? Because it traps particulates, it traps bacteria, it traps lots of things that are not wanted. Medical research facilities, the National Institutes of Health use it, the Centers for Disease Control use it, and ironically, of the 6 bullets that are up here, the most demanding is the computer chip manufacturing industry, where HEPA filters are used in order to cull the particles out of the air, because small particles, even minute particles in a computer chip manufacturing facility, are deadly for the silicon wafers that they're trying to make. HEPA standards removes particles as small as 0.3 of a micron. That's what it's rated at. Micron is 0.001 millimeter, a thousandth of a millimeter, a millionth of a meter, and it is verified to be 99.97% efficient at those particulate levels. Particles smaller than 0.3 microns, which are too small for most lab instruments to measure, are filtered with higher capture rates because it's fluted, because it creates a tortuous path. In other words, it's not a straight line through the filter. It's a tortuous path, means that we are capturing particles that are much, much smaller than 0.3 microns. Using the diffusion principle, the Power 5 can intercept particles as small as 1/10 of a micron. That is as much as 10 times smaller than the size of a Staphylococcus bacteria. The result is the cleanest air you'll ever experience. And again, I'll go back to the HEPA, and I'll go back to that whole series, the parfait, that sandwich of filtration that we have. The likelihood of radioactive particulates that are in the air making it through that filter untouched is extremely low, and the ability for the filter to capture and retain those particulates is very high. So if I were living in Tokyo, I would be doing 2 things. I would be making absolutely sure that any tap water that comes into my house that I'm going to cook my food with or drink or water my family water, my pets, my plants, or feed to my kids, I would make sure that it is filtered absolutely through activated charcoal system like the PyMag under countertop or the Aquaport gravity feed system. At the same time, what I would do is I would keep my doors and windows closed as much as possible, and I would have a Power 5 Pro cranking full-time on turbo to make sure that I can remove as many of the particulates that are in the air, whether they're radioactive or not, and have them trapped in this 5-stage filter that's in the Power 5, rather than having them trapped in my lungs and integrating into my system. A little bit about negative ions. This is extremely important for the overall feeling of wellness and relaxation that you get when you're near the Power 5 or you have that near your bed. These are ions. Negative ions are charged atoms or molecules. It's counterintuitive that negative ions or negatively charged oxygen atoms help us feel better, and positive kind of depress us a little bit. High amounts of negative ions present in forests and near waterfalls. A walk through a forest or by a mountain stream feels soothing and relaxing. Negative ion technology has been used extensively in Asia, in Japan, known as Shinrin-yoku, or forest air breathing. It helps to balance the air conditioning. A lot of negative ions in the air can be affected by several factors. Household air conditioners actually reduce the number of negative ions. Negative ion generator can help to balance that out. Ozone. I don't think I need to belabor this. Ozone is dangerous. It is a dangerous form of oxygen. U.S. EPA classifies it as a toxic gas. American Lung Association cites thousands of scientific clinical studies that prove that it's harmful, and yet many of the home filters and purifiers on sale actually produce ozone. Some brag about it. And it's quite amazing that there are still units out there that will tell you, if you've had this unit in your bedroom during the day and the doors and windows have been closed, that you should open the windows and air out the room before you enter it, because the levels of ozone may be too high. We take a directly opposite tangent. We don't want any ozone. We want to make sure that not only for our customers, for our wellness consultants, that we don't pose any danger at all by having any ozone. We also understand that the state of California has made it illegal for any home air filter device to emit ozone, and we were compliant way before they passed those regulations. Other features are natural light operation, doesn't require any UV lamp. This saves energy and also doesn't produce any ultraviolet rays, which could, again, create ozone. Quick, easy filter replacement. Anti-charging material, resists static electricity buildup and avoids shock. Also has a particle sensor, detects ambient pollution levels. Other features include the automatic modes, lightweight design for portability, remote control, which is nice, a multifunction that allows you to turn it on or off when you're lying in bed and you're too lazy to get up. Or if you just decide, it's time for me to boost it up to turbo or to throttle it back. This is my next slide, or my almost next to last slide, is one on radioactive exposure, and I'm not sure whether or not I should be putting that on. I guess I'll do it since I have it, and I don't want to create more questions than I answer here. But if you take a look at the little blue bricks, the little blue blocks that are on the left-hand side, this is a chart of ionizing radiation dosage that a person can absorb from various sources. The unit for absorbed dose is known as a sievert, or big S little v, and measures the effect a dose of radiation will have on the cells of the body. One sievert, taken all at once, will make you sick, and too many more will kill you. But if we safely absorb small amounts of natural radiation daily, and it says, if you take a look at the bottom, you'll see where one of these little blue blocks is equal to 0.05 microsieverts. Somebody who sleeps next to you in bed is actually giving off radiation, small amounts, but still their body's giving off a small amount of radiation, which is equivalent to one of the small blocks, which is 0.05 microsieverts. If you live within 50 miles of a nuclear power plant for a year, you're going to get a little bit less than 2 of these small blocks, which is 0.05 microsieverts. Eating a banana gives you 2 blocks or 1 microsievert, because the constituents in a banana actually have that much radioactive material in them. It's not very much, but there's always some, and it's measurable. Living within 50 miles of a coal power plant for a year, you get 0.3 microsieverts. And then extra doses, and you can see an extra dose from spending 1 day in an area with higher than average natural background radiation, such as a Colorado plateau, is 1.2 microsieverts, or you can see here 25 of these little blue blocks. If you go ahead and get a dental or a hand x-ray, you're going to get 5 microsieverts, which is 20 of these blocks. An extra dose from 1 day in an average town near Fukushima, which is going to be approximately 3.5 microsieverts as of March 17th, would have varied quite a bit. And then if you take a look at the fourth one down here, you've got 25, you've got 10 microsieverts, which is the background dose received by an average person over 1 normal day. And then the last one in blue is an airplane flight cross-country from New York to LA, where you get 40 microsieverts of radiation. And then we go to some of the more heavy stuff, which is in the green. And it changes the scale. We go from blue to green, where the green is equal to 20 microsieverts, which is essentially the same as an X-ray, a chest X-ray. And then all the doses of the blue combined give you 3 of the little green blocks. And I think you can read some of these here, and I'm not going to go through all of them. But you can see that a mammogram will give you 3 millisieverts, and the normal background for a year, about 85% of it from normal doses, nearly all the rest is from medical scans, is about 3.65 millisieverts. Then I'm going to go to the next slide, which shows you higher doses, and that is the kind of radiation that you will get from some of these nuclear reactors and some of the trouble that you can get in. And the very last one, which is showing you what a sievert looks like. 50 sieverts here is 10 minutes next to the Chernobyl reactor core after the explosion and the meltdown. So I don't know if that's helpful for people. You can find this online. Just Google radiation dose chart. I'd love to give you a copy of this if you wanted it, but I don't have the copyrights to this. So there is one interesting little joke here that I'll point out. it talks about getting a tenth of a microsievert from eating one banana, and then it says using a cell phone, you will get 0 microsieverts. A cell phone's transmitter does not produce ionizing radiation and does not cause cancer, but there's an asterisk that says unless it's a banana phone, which refers to the top. Okay, so in closing, I wanted to remind everybody that we will do this again in the middle of May, the middle Wednesday of May, which is May 11th, and we'll have a webcast where I will talk a lot less, and Dr. Peter Goldberg will talk a lot more on magnetics, MagSteps, and the Nature Rest sleep system, the RAM magnetic pattern that he devised, how he came up with the RAM pattern, what he thinks about RAM, what he thinks about magnetics, what he thinks about cellular energy, and what he thinks about magnetism and magnetic energy in general. So I hope everybody can tune in and enjoy that one. And I hope I wasn't too crazy tonight talking about the Fukushima disaster and the radiation, but I kind of wanted to set the stage because I've been getting a lot of questions about filtration, about activated charcoal, about how our systems could help, whether people are in Vancouver or Seattle or wherever they may be on the West Coast. If they're worried about it, what can you do to maximize your chances of being safe? I don't think anybody on the West Coast, whether it's LA or Seattle or Vancouver, is in danger from anything coming from Japan. But for those who just want to rest a little bit easier, go ahead and continue to filter your water and your air using the Niken systems, and I think you'll rest a little bit easier. So that's it for me. Thank you so much. Thank you for joining, and I will see you in about a month. Bye-bye.